Find the town judge is an example of a problem where you really should just do exactly what it says. It's an easy problem, and let's start by reading it. In a town, there are n people labeled 1 to n. There is a rumor that one of these people is secretly the town judge. If the town judge exists, then, and these are 3 different conditions, 1, the town judge trusts nobody. 2, everybody except for the town judge trusts the town judge. And 3, there is exactly one person that satisfies properties 1 and 2. You're given an array trust where trust of I equals A of I and B of I, representing that the person labeled A of I trusts the person labeled B of I. Return the label of the town judge if the town judge exists and can be identified, or return -1 otherwise. So let's go through the examples first and foremost. So the first one is n equals 2. And the first, I wouldn't say tricky, but thing that should be noted in this problem is that n is 1 indexed for the purposes of the array. So in this case, there are 2 people. So we have person number 1 and we have person number 2. And it says that person 1 trusts person 2. So then let's go over our conditions. So in this case, the town judge is number 2. So the town judge must trust nobody. You can see there are no arrows going out of 2. And everybody except for the town judge trusts the town judge. And you can see that in this case, yes, 1 trusts 2. So everybody except the town judge trusts the town judge. And there is exactly one person that satisfies properties 1 and 2. So nobody else satisfies those properties. Let's go to the third example. So we have 1, we have 2, and we have 3. So person 1 trusts person 3, like that, and person 2 trusts person 3. So, is there somebody that trusts nobody? That would be number 3. Everybody else trusts somebody. Is there somebody such that everybody trusts them? Yes, 1 trusts 3 and 2 trusts 3. And is there only one person that satisfies this condition? Yes, person 3. And then finally, we can look at example number 3. We have 3 people. And person 1 trusts person 3, person 2 trusts person 3, and person 3 trusts person 1. So, is there anybody that trusts nobody? No. So in this case, we would return 1 because nobody satisfies the town judge. So step 1, how would we go about solving this brute force? Well, we could loop through every single person. So I guess let's take this example. Let me make that line a bit thicker for you. We could say take this example here, and we could look at person number 1, and we could look at each of the 3 conditions and see if they satisfy it. Well, the town judge has to trust nobody, so we loop through the entire array. In this case, it's, 1, 3, and 2, 3. We loop through the entire array and see, does person number 1 trust anybody? And we would see here that, yes, person number 1 trusts number 3, so they can't be the town judge. Then we could say, okay, what about person number 2? Well, person number 2 trusts person number 3 here. After we loop through the entire array again, they can't be the person. Then we would look at person number 3, loop through the entire array. Okay, person number 3 doesn't trust anybody. Does everybody trust the town judge? Okay, so we have to go through every answer again and make sure that everybody trusts number 3, and then we'd have to make sure that that's the only one. So that would be solving it through brute force, but obviously we can do a little bit better. In this case, doing it by brute force, you'd first have to go through every single person, so that would be O of n, and then you would have to go through every node, so that would be every adjacency. So that would be, I'd say, like O of adjacency. So, I mean, you'd probably be fine in an interview if you said this was n squared, but obviously we can do better than that. Okay, so as usual, step 3 is identifying the pattern. Here it should be pretty obvious. This is a sort of graph where each person is a node and each adjacency, each trust is an edge. So here, I mean, it's pretty easy. It is an easy problem, so it's easy to see what it's asking you to do. There's 3 conditions, and each of the conditions relate to the number of people who a node trusts, and then the second condition is the number of people who trust this node. And then condition number 3 is uniqueness. So it should be pretty easy to see here that all we really have to do is for every node, keep track of the number of people who this node trusts, and keep track of the number of people who trust this node. In other words, we're just going to keep 2 different matrices. We're going to have one for, we'll call this outgoing. So we'll say this is int out, and there's going to be n adjacencies, and then there's going to be a second one in. So this is the number of people who trust this node, right? So we're going to have these two arrays. And what we're going to do is we're going to loop through all of the adjacencies. And if a node trusts another node, then, for example, if we have 1, 3, then 1 trusts 3. So that means when we get to 1, 3, out of this case, it's actually going to be 1 minus 1, because remember, it's 1 indexed will be minus minus, and then in, because now 1 trusts 3, so 3 minus 1 plus plus. And the condition to find the judge node is number of people who this node trusts. So if there is a node that this is 0, and people who trust this node, so everybody needs to trust the judge except the judge, this needs to equal n minus 1. If there's any index that satisfies this, and it's the only index that satisfies this, then we found the solution. So let's go ahead and code this up. Okay, so we're going to code it in C++, but remember, this should be simple for any language. As we said before, the first thing we're going to need is, well, we're obviously going to need the return value. Since if we can't find a solution, it's going to be -1. We'll just have it at -1 to start. Then what we're going to do is we're going to have our two arrays. So the first one is going to be vector int in, and that one is going to be equal to n, and we're going to fill it with zeros. And then we're going to have vector int out, fill it with n, fill it with zeros. Okay. So now we need to actually fill these arrays. So we're going to loop through every adjacency in the trust vector. So for, let's just call it array, or let's call it adjacency in trust in. So in of adjacency, that's the second one. And remember, they're one index, so you need to do this. And out adjacency 0 minus 1. Just like that. Okay. So now we need to actually search for our solution. So let's go through every person. So n for int I equals 0, I is less than n, I plus plus. So what are the conditions? Well, if everybody trusts this person, so if in of I equals, remember everybody but the judge, so n minus 1, and the judge trusts nobody, so out of I equals 0, then this is our solution, right? Well, not so fast. Remember, there can only be one person who is the judge. So if for some reason there's another person, we need to make sure that they're not included. So if ret does not equal -1, so we already found a solution, then we actually need to return false. Otherwise, ret equals I. Okay? So if everything's all good, we will go ahead and return our answer. So let's make sure this works. Oh, well, again, remember, it is 0 indexed. So if we do this, we actually need to do +1. If you want, you can make your in and out matrix 1 index, but it's whatever you want. So we'll go ahead and submit. Oh, and we have a problem. So this is, again, another problem with our logic here. If our ret is still -1, that means we don't have a solution, and we shouldn't return -1. So in that case, we'll say, does ret equal -1 question mark? If so, then return -1. Otherwise, return our actual solution. +1, apologies. Okay, so that's the solution, and thanks so much for watching.